Recently in class we talked about standard deviation as a statistical measurement of the variation in data. But it was maybe a little confusing and a little confused. In some classes we talked about penguins, which I drew kind of like this, which was maybe adorable and maybe just a little bit terrifying. So I've created a slideshow with adorable penguins to help us understand. We imagined two populations of penguins. Eyeballing them, you think, one group seems to be bigger than the other. So you take your meter stick and you measure how tall they are, and you take the average, right? And let's say you find out that this group over here on average is 1.2 meters tall. And then you go over the other penguins with a longer measuring stick. Maybe they're on average 1.7 meters. When you look at those averages and you look at the penguins all lined up like this, you should feel fairly confident, I feel very confident that those averages are meaningful, that they indicate actual differences in these two groups. And if we saw a lonesome penguin wandering around looking for its population, where are my people? My penguins. You could also feel fairly confident that that penguin belongs over here with this population and not over here with this population. Let's imagine a different scenario, however, that when you go to measure the penguins, and here's your first population of penguins, and you take out your meter stick, you notice there's quite a bit of variety here. But you take all their measurements and you again average them, and you get the same average, 1.2 meters. Okay. Right away, hopefully you are all saying, wow, there is an important difference between these two scenarios. They both have the same average, 1.2 meters, but there's a lot more variation in this population than this population. The average of 1.2 means a lot more, is a lot more representative of this population than the average means for this group. Let's continue our scenario. The other population that you thought were kind of bigger, you find them, their average height is 1.7 meters, just like the ones in the previous scenario, right? Same averages. 1.7 meters, 1.7 meters. And yet again, the variation here makes that average less meaningful. If you saw that same lonesome penguin wandering around, let's say it's about 1.7 meters tall, right? Its height matches the average over here, but how confident would you be saying it belongs with this group and not this group? Not especially. Why is this important? Because as thinkers in the world today, when people bandy about, oh, the average, this, that, and the other thing, you want to be asking yourself, well, how meaningful is that average? The average American does this or that. How much variation was in that data? How representative was that of anything meaningful? In your science futures, you're going to need to be able to assess how meaningful averages you take in your data are. And in your science fair project, if you are comparing averages, which many of you are, you're creating bar graphs to compare averages, I want you to have in your head asking yourself, well, how meaningful is this? There are lots of statistical tools to assess how meaningful comparing two populations, two groups of data are. We're going to just get the tip of the iceberg in terms of calculating and in your graphs representing standard deviation, which is basically the starting point for a lot of more robust and more meaningful statistical tests, which we won't get into the nitty-gritty of, but you can look forward to in future science classes and statistics classes. But I want all of us to have a sense of what standard deviation is, and it's just a statistical way of representing how much variation is there in your data. So the math behind calculating standard deviation is represented with this equation. It's essentially taking the difference between each reading and the average, squaring it, dividing by the sample size, and taking the square root of that. Luckily for us all, spreadsheets can do that work for you, saving lots and lots of time and number crunching. In Google Sheets or Excel, they're essentially the same on many things. You click on the cell where you want to put your standard deviation. You click equal sign and you start typing ST. You notice that standard deviation is the first formula that pops up because it's so frequently used. So you can click on it there. And then it has a parenthesis saying, well, what do you want me to take the standard deviation of? Highlight your data. Don't highlight your average. Right there, that 20.2 was the average that we calculated in class. You'll remember that. So highlight the actual data points, not the average. And push enter, and it calculates your standard deviation for you. Now, you can do that again, equals ST and highlight. Or, as you guys recall, you can just copy and paste, and Google Sheets is smart and knows, oh, I know what you're doing. You want to do that same formula for a new set of data. And you can look up here and see, yeah, B2 to B11, that's right, column B, cell row 2 through 11 is what I wanted. And so it calculated your standard deviation for you there. Now then, for putting it in your graph, let's say you've already made your bar graph and you want to put the standard deviation bars, because those bars help you understand visually how much error, essentially, there is in your average, right? So to do that, you go to Advanced Edit, and with your bar chart, you need to remember at some point you're going to need to switch rows and columns, this click thing, and you'll know because it automatically makes your two columns different colors. For whatever bizarro reasons, you need to do that so that it understands there are two different groups and it'll let you edit independently these bars. All right, so in customization, you can go all the way down to the bottom where it asks you for series. You don't want all columns, you want your column, we do them one at a time. So your fertilizer A column, click on that. And this little data labels is where you can put the number in the bar of the actual average. That seemed kind of fun, so we did that. Underneath it says error bars, right? So depending on what statistic you're using, like I said, there are lots of different statistics available to show whether something's significant or not. We're showing standard deviation, which is a number, not a percent, okay? So you click on constant and then enter the number. I just did it to 2 decimal points. We're doing this quick and dirty. You could enter all of them, that's fine. Once you do that, it draws the bars, right? So if I had done it wrong, I mean, if I had accidentally put 322, you can see, wow, yeah, that totally changed our graph. So it automatically updates your graph with those bars. Similarly, you can go to your second bar, fertilizer B, and that total, scoot this over, 3.938, and so we've got bars for both of those, so that just like we could visualize just eyeballing our penguins, wow, there's a lot of variation in that average. Well, all right, now in your graph, you can look at your graph and see, wow, there's a lot of variation or not much variation in that average.